Hi, welcome to another lesson with Dr. Hill. Today what we're going to do is we're going to look at a little bit more on pedigree charts for our National 5 biology. What I said in the last lesson on pedigree charts was that the haemophilia in the European royal family um, was passed through several generations and was observed coming up in individuals. Now, haemophilia in this particular case is a little bit more complicated than that because it was actually a gene that was on the X chromosome, which meant that a recessive phenotype could turn up in males quite easily because if the males get the X chromosome with the the recessive allele on it, the other chromosome is a Y chromosome, which doesn't have the gene at all. So recessive alleles can show up really easily in males if the gene is on the X chromosome, and we'll see that when we look at the chart. So it's a little bit more complicated than a straightforward crossing, but with human families who tend to try and not interbreed, although royal families try to keep their blood blue, don't they? And they try to keep their relationships in the same family as much as possible, so cousins are marrying each other. But even so, it's quite hard sometimes to follow recessive alleles in human populations when they're on the autosomes, the non-sex chromosomes. But let's have a look at the screen here, because on the screen we have the chart, and I'm just going to talk you through it. So this chart starts off with Prince Albert and Queen Victoria, and Queen Victoria is a carrier for this. So this chart's a little bit different to the one I've taught you. In this case, the males are represented by this symbol, the little pointy arrow thing. This is the old-fashioned. Well, it's a symbol for male, and the female is this symbol here with the cross at the bottom, and their crosses are linked and then come out with a single line. So that's how you follow an individual cross, and then the offspring are the drops from that single line that comes up from the parents. So let's have a look at what's going on here. Well, Queen Victoria was a carrier for this allele, the haemophilia. So her X chromosome, one of her X chromosomes, because females get two X chromosomes, one had a normal gene, normal dominant allele that was functional, and one of her X chromosomes is carrying the dysfunctional allele, the one that doesn't work and causes haemophilia. It's a blood clotting disease. So blood clotting doesn't work if you get this allele either as double recessive or as a single copy in a male, because they don't get two X chromosomes, they only get one X chromosome. So if we look at this, we see that the offspring of Queen Victoria, we had Victoria herself here, the Victoria Junior, was not a carrier, but Alice was a carrier. So Alice inherited her X chromosome, the recessive allele on the X chromosome that she got from her mother, Queen Victoria, whereas the X chromosome that she got from Prince Albert, of course, was non-infected. It's not a carrying X chromosome. So she is still a carrier. She's got an X chromosome. One of her X chromosomes has the recessive allele. Leopold, unfortunately, he was the unlucky one. He was a male. He didn't inherit an X chromosome from his dad because he inherited a Y chromosome from his dad. And that meant that when he got the X chromosome from his mother with the defective allele on it, he shows the disease haemophilia. And so he was expressing the allele. So you see here the light pink are the carriers, and they're nearly all female in this case, and they will all be female if you're carrying it. If you're male and you've got it, you're going to have the disease. And the male here is expressing the disease. Queen Victoria had another daughter, so you can see it was pretty much unlucky in the family here, because you could expect a 50-50 split, but it's not always the case. Remember, we talked about randomness in genetics. You could say that 50% of Queen Victoria's offspring are going to be carriers and 50% or have the dysfunctional allele, and 50% aren't. But in this particular case, 75% of the offspring had the dysfunctional allele, because every single individual has a 50-50 chance of getting it. Right? It's not guaranteed if you have 4 offspring that 2 will have it and 2 won't. So that's an important point. Every individual offspring had a 50-50 chance of getting it. Okay, you can roll a dice and roll 4 sixes if you want, even though there's a 1 in 6 chance of rolling a 6. So 50-50. Now Leopold, he fell in love with Helene, and they had children. And because he has to give his X chromosome to his offspring, who are female, the females become carriers. He does not give his he doesn't give his X chromosome to his male offspring because he gives a Y chromosome to them, so they're free of the disease. So the X chromosome passes from Queen Victoria into Leopold, into Alice, and then into Alice's son, who got unlucky, was Ruprecht. Good names, these guys, haven't they? Great names. So again, let's follow Beatrice. Beatrice was a carrier. So Queen Victoria's X chromosome, carrying the dysfunctional allele, went into Beatrice's, one of her X chromosomes. She got that from her mom, and she got another X chromosome from her dad, which was fine. If Prince Albert had been a carrier for had expressed the disease, say he was Leopold and was red here, everybody would be getting the disease, pretty much, apart from half of the girls. Half of the girls wouldn't get the disease, but they would all be carriers. So anyway, Beatrice got unlucky. She was a carrier, and she married Heinrich, and they had offspring. And again, you'll see that 3 offspring all had the allele. Again, it's not a 50-50 shot. There's every chance. There's a 50% chance of not getting the recessive allele, but all 3 of her children did get the recessive allele. And the 2 males expressed the disease because they didn't have another X chromosome. And another Victoria, this is Queen Victoria's grandchild, is a carrier. And again, this passes on into another family. This is the Spanish royal family over here. So, as you can see in the European royal family, if you look at this chart carefully, you can follow the path of the dysfunctional allele through the population. So, just to summarize there then, you can use pedigree analysis, and again with the European royal family, we don't have to go back and genetically test everybody. It's well recorded who had haemophilia and who didn't. And from knowing who had the haemophilia, you can predict who the carriers were. Some of these offspring at the bottom that we see, if we go back and look here, the ones right down here at the bottom, it might not be clear yet whether these are carriers, right? Until they actually get married and have children, we won't know if they're carriers or not. So that's all pretty interesting stuff. If you look at these pedigree charts and look at different ones for different diseases, and when we look at the exam questions, we'll see more examples. So that's the end of today's lesson, or this particular lesson, and we'll move on to some problem solving in our next lesson. Thanks for listening.